Hi, welcome back to my channel, and for today's video, we will be talking about the arithmetic and geometric sequence. So this is in response also to everybody who messaged me on Facebook requesting if maybe I could provide a discussion about arithmetic and geometric sequence for their online class. So thank you so much for those who messaged me, and I really appreciate that. I will do all my best to grant your request. So for today, I will have to discuss to you about the arithmetic sequence and geometric sequence.
Okay, so let's now talk about the arithmetic sequence and geometric sequence.
Down there on the subscribe button, and also click the notification bell button for you to be able to be updated on a lot of videos that I'll be uploading soon.
Okay, so let us start with the arithmetic sequence. So arithmetic sequence is a sequence of numbers such that the difference of any two successive numbers of the sequence is constant. So example, if you would have sequence of number, let's say 5, next one is 7, then 9, then 11. So the difference between two successive numbers is constant. So in this case, the difference between the successive number is 2, the successive number is another 2, and this one is another 2. So the rule is you have to make sure that the common difference of between two successive numbers are actually the same. So example, the difference of the first term and the second term is 2. So the difference of the third term and the second term is also 2. And so with the other terms. So that is the arithmetic sequence. So for this, in this case, these are the terms here, and we label these as, let's say this is A1. So that represents for the first term of the arithmetic sequence. We have A2, we have A3, and A4. So that means we also have AN, so that means that's the n term of the arithmetic sequence. Now these two here as the difference between two successive numbers, we call that as common difference, or the common difference denoted by D. So this is a common difference. I'm sorry. That's it. So if we are given with, let's say for example, we are given with the first term and we're looking for the nth term. So that means, let's say, the 10th term of a sequence. So it would be very difficult for us to enumerate and then get the 10th term, because what if, let's say for example, you're given with the first term, second term, third term, but you are asked to find the 1 millionth term. So it would be very difficult, and it would take so much time enumerating what would be the 100th term. So therefore, we would establish a formula for that. If you notice, let's say I have 5, 7, 9, 11, 13. Excuse me. If you notice, the common difference here is 2. So this is the first term. This is the 5th term. Now, take a look into this. How many 2 you would find as the common difference before you get to 13? So that is, there are 4. That means you have to go through with 4 D's. That D is the common difference. This is the 5th term. So which means that in order for you to get the 5th term, you have to go through with 4 D's and to be added to the first term. So technically, that 4 is equivalent to 5 minus 1. So basically, the 5 here is the n, because we're talking about the nth term, the 5th term. So in this case, to look for the 5th term, you need to have the first term added by the 4d. So that means n minus 1d. So basically, in general, this is a sub n. That's a sub n is equal to a1 plus n minus 1d. So this is the formula in getting the nth term of the arithmetic sequence. So say, for example, let's continue the sequence here. 13, next to that is 15, 17, 19. Correct me if I'm wrong. I have 21 here and 23 here. So that's 6, 7, 8, 9, 10. So this is a sub 10 or the 10th term. So let's try if it matched on the formula. So to solve for a sub 10, we have a1 plus n minus 1 times, what's the difference? That's 2. So this is 10 here. So this is 10 minus 1. So a1 is 5. That's 9 times 2, you get 18. Am I correct? So that's 9. 10 minus 1, you get 9. Times 2, you get 18. So 5 plus 18, you get 23. So it matches here on the formula. So therefore, the formula for getting the nth term of the arithmetic sequence is this one. That's all. So, okay, we will consider some examples here on applying our knowledge for the arithmetic sequence. So first is find the 100th term of the arithmetic sequence with the first term of 5 and the common difference is 3. So you have the formula here to find for the nth term, which is a1 plus n minus 1 times d. So you're looking for the 100th term, so therefore your n is 100, right? So that means you have a sub 100, so that means you're looking for the 100th term. Your first term is 5, so that's 5 plus, what's 100? That's 100 minus 1 times common difference of 3, so that's gonna be 5 plus, that's 99. So that's 99 times 3. And so you get 5 plus, what is 99 times 3? That is, sorry, that's 27, 29. Correct me if I'm wrong. That's going to be 27, 29. So adding this one, you get 302. So therefore, this is the 100th term of the arithmetic sequence, starting from the first term of 5 with a common difference of 3. Okay, let's answer number 2 here. Find the 50th term of the sequence with the first term of negative 10 and the common difference of 4. So same formula, you have a sub n. So let's go now to a sub 50. So that's a sub 50 because you're looking for the 50th term. That's multiplied by, I'm sorry, my bad. That's first term is negative 10. So plus, your n here is 50. So that's 50 minus 1 multiplied by 4. The common difference is 4. So that's negative 10 plus, this is 49. Am I correct? So this is 49 times 4. So this is equivalent to 98. So 98, that's gonna be 196. So negative 10 plus 196. Correct me if I made a wrong calculation here. So that's gonna be 186. So that's the 50th term of the sequence, starting from the first term of negative 10 with a common difference of 4. Okay, so if you have any questions or clarification, you don't hesitate to comment down there so that everyone is aware. Or maybe I made a wrong calculation here. But just so you know, the method here is actually correct. So that will be the formula for getting the arithmetic sequence. Okay, so for number 3, find the common difference of the arithmetic sequence with the first term 10 and the 20th term is 48. So this is somewhat a kind of a tricky thing, but you just have to stick with the formula and everything else follows. So in this case, our first term here is 10. Our 20th term is 48. So you're solving for the common difference, the D. So you have a to the sub 20, rather, that's a sub 1 plus n minus 1 D. So solving for D in this case, I'm gonna add both sides by negative a sub 1. So I have n minus 1 times D, that's equal to a a20 minus a1. Of course, I multiply both here the left side by minus I'm sorry, I add both sides by negative a1, so it has a minus a1 here, but this will be canceled on the right side. And then I flip the position, so the right side of the equation becomes the left side becomes the right side. It doesn't matter. That's the rule in algebra, that it doesn't change anything if you're flipping the oppositions. And then divide both sides by n minus 1, so you'd get d equals a sub 20 minus a sub 1 all over n minus 1. So in this case, your a sub 20 is 48, your a sub 1 is 10, your n here is 19. So therefore, that's 48 minus 10, you get 38. Divide by 19, you get 2. So therefore, the common difference is 2. That's it. Okay, so let's have another example here. So number 4, an arithmetic sequence has a common difference equal to 10 and its sixth term is equal to 52. Find its 15th term. So in this case, for number 4, in order for us to locate the 15th term, that is we have this a1 plus 15 minus 1 times d, right? However, we don't have a1, so what are we gonna do? We will look for a1 first. So, but we're given with a sixth term, so that's not a problem. So we have a sub 6, so that's sixth term, is equal to a1 plus n minus 1, so that's 6 minus 1, so you get 5, times your d is 10. So you have a common difference equal to 10. So therefore, your sixth term is 52. So I'm gonna solve for a1. So that's gonna be a1 equals a6, which is 52. I'm gonna transfer this, so that's equal to 50. So that's 50. So a1 here is 2. Let's double check. A6 is equal to A1 plus 5 times 10. Your 5 is n minus 1. Your n is 6. Because you're actually working on the sixth term. The common difference here is 10. So that's it. So your A1 is 2. So therefore, solving for 15th term, you have your A1 is 2 plus this is 14, right? And your common difference is 10. So this is equal to 2 plus 140, so this is equal to 142. So therefore, that's the 15th term of the sequence. That's it. Okay, so let's go to geometric progression or geometric sequence. So a geometric sequence is a sequence of numbers that follows a pattern where the next term is found by multiplying by a constant called a common ratio. So let us consider, for example, you have sequence of 2, 4, 8, 16, 32. So this is a geometric sequence. The second term is found by multiplying that by 2 from the first term. We get the third term by multiplying the second term by 2. And the fourth term by multiplying by 2 from the third term, and the fifth term is multiplying by 2 from the fourth term. So these two here is what we call the common ratio, R. So if you notice, this is the first term here. This is the fifth term here. how do we get the fifth term, supposing that we don't have to enumerate them all? So this is basically 32. This is equivalent to how we write that in 2 times 2 to the 4. Observe that 2 times 2, I'm sorry, 2 to the 4 is 16. So multiply by 2, you get 32. So basically, in general, to get the, because this is the fifth term, this is the first term, this is your r, and this is actually n minus 1 because your n is 5. So in general, you can get the nth term by multiplying the first term by r to the n minus 1. So this is the formula in finding the nth term of the geometric sequence, having the first term a1 and your r as a common ratio. That's it. Okay, so let's consider this example. Number 1, find the seventh term of the geometric sequence with a common ratio of 2 and the first term of 5. So, solving for the seventh term, so that's going to be a sub 7 equals a1 r to the 6 because that's 7 minus 1. So that's equal to a1 is 5. That's 2 to the 6. So 5 times, what is 2 to the 6? 2 to the 6 is 2 to the 6 is 64. So 5 times 64, that's gonna be 320. So therefore, the a sub 7 of, the seventh term of the geometric sequence is 320. Now let's go to number 2. Find the first term of the sequence with the eighth term of 10,935 and the common ratio of 3. So solving for the, supposedly if we solve for eighth term, it's gonna be this way, r times 7. But since we're solving for a1, so that's gonna be a8 over r to the 7. Your A8 is 10,935 and your R to the 7, your common ratio is 3 to the 7. Okay, so that's gonna be 10,935. That's over 3 to the 7. You do that in your calculator. I have here as 2,187. So that means your a1 is 5. That's all. Okay, so since we're actually talking about the geometric sequence, so we also have geometric sum. So basically, this is the sum of the first n terms of the geometric sequence. So given that you have a1 up to an, so if you're going to add this one here, this is equivalent to the formula a1 times 1 to the r to the n over 1 minus r. So I'll give you one exercise. You'll be the one to derive how did we get this formula. So if you have already known the answer, then you can comment down there and tell me how did you get that. Or if you have any clarification, you can message me on the Facebook page. But basically, this is just this is the formula, and I'm not gonna derive it anymore for you. You'll be the one to do it for yourself. And by the way, if you notice on the formula, that's an, so it involves the a1 rather. So it involves the a1, the common ratio r, and the n at which we're looking for the n, the sum of the n terms. So n terms rather. So that formula tells us that we don't need to find the 10th term of the geometric sequence when we are solving for the sum. So say for example, you have 2, 4, 8, 16, 32. So if we are interested to find the sum of the first, let's say, of the first 10 terms, so that's gonna be s sub 10, that's equal to 2 times 1 minus, your r here is 2. So that's 2 to the 10 over 1 minus 2. So basically this is 2 times 1 minus 2 to the 10, so that's 2 to the 5 is 32, so that's 32 times 32. I think I'm correct. So 1000, so 1 minus 1024 over negative 1. So this is 1023. These are both negative, so this becomes positive, so that is 2046. So this is the sum of the first 10 terms of the geometric sequence. That's how I'm. Okay, so we will consider a problem here involving the geometric sequence. So I will just present to you the solution on how to solve this one, but you'll be the one to solve it via your calculator. So here, Jen has purchased 20 books. The first book costs $1. So if you are going to write that one, so let's denote A1 as the first book, so that's $1. That's A2, that's the second book, that's $2. A3 is $4, A4 is $8, and so on. So this actually forms geometric sequence. So the common ratio is 2. So if you are looking for the sum of the 20 books, that means your sum of the 20, the first 20 terms of the geometric sequence. So that's gonna be this way. I'm sorry, 20. So that's A1 is 1. So that's gonna be 1 minus r to the that's 2. So that's 2 to the 20 over 1 minus 2. So this is now the sum. So you're pretty sure this is positive because the numerator is negative, the denominator is negative. So that's the sum. So that's the total amount John has to pay for the 20 books. That's it. So I guess that's all for now. So what we have learned today is we know the arithmetic sequence and its arithmetic sum, and we also have the geometric sequence and its geometric sum. So these two are actually just fragments of some types of sequences. In the high school mathematics, I think this is the basic sequences that we are actually dealing with. I don't know if you have undergone with harmonic sequences, Fibonacci sequences, or Lucas sequences, but in this case, I am focusing with the arithmetic and geometric sequence. But if you have any questions or clarifications, don't forget to comment down there below and click on the subscribe button for you to be updated on a lot of videos that I have uploaded and I will be uploading soon. So thank you so much for watching and have a great day to you. Bye for now.